Cartesian coordinate system. Now, do you guys remember that word Cartesian, or are you looking at that saying, what the heck is she talking about? Okay. Okay. Folks, Cartesian coordinate system is what you've been doing since you were little. It's just your XY axis. Okay, it's your rectangular coordinate system. But the official name is the Cartesian coordinate system. Okay, so when you talk about the XY axis, that's what Cartesian is. So Cartesian coordinate system, it's the rectangular coordinate system. It is the way you've been graphing since, when did we start learning graphing? Elementary, maybe? I don't think it was later in middle school. I feel like it was elementary, but I don't know. I'm guessing here. So with that in mind, let's talk about a little bit of information here. Basic review, folks. Tell me about my axes.
X, left to right, Y.
Okay, horizontal axis X, vertical axis Y. Okay. Tell me about an ordered pair. What do we know about ordered pairs?
X, Y.
Okay, an ordered pair goes in the order X, Y, right? Like that, so you can see it. So if we're asked to plot the point, negative 5, 8, how do we plot the point, negative 5, 8? Okay, negative 5 is left to right 5, so left 5. Positive 8 is up or down 8, so up 8. Okay, we'll have to just make our tick marks as we go. So negative 5, 8 is approximately there. Right, left 5, up 8. I'm going to label that as coordinate A because it is problem A. Before we move on to B, the question also asks what quadrant is each point in? What do you remember about quadrants?
There's like 1, 2, 3, 4.
Okay, so quadrant 1 is over here in the upper right. And it is your positive quadrant, right? And then we go, you remember, counterclockwise from there. So 1, 2, 3, and 4. Traditionally, quadrants are written with Roman numerals. I'm not saying you have to use Roman numerals, but traditionally in math, that's what you see, so I did. So negative 5, 8, we can agree is in quadrant 2. This is all old news, right?
Yep.
Slow me down if I go over something too fast. Okay, what about B? 0, negative 2. Where is that?
Down 2.
Okay, so the 0 says left to right 0. The negative 2 says down 2. So that is coordinate B. What quadrant is this in?
Three and 4. It's not in one.
I'm going to go with it's not in a quadrant. It's not in a quadrant because where is it?
On the line.
Yeah. So which quadrant is it in? I'm going to say none. If you want, you can put it in parentheses, or I'm going to put it in parentheses that it's none because it's on the y-axis. Okay. Point C, 5, negative 3. Where am I going to get to point C?
Right down.
Okay, right 5, down 3. That is our point C. Which quadrant is point C in?
4.
Okay. And 4. We know in Roman numerals that 4 is IV because it's 1 before 5, right?
Yep.
Okay, what about D? 4, 0.
Go right 4.
Okay. Right 4. Up or down 0. Which quadrant is that in?
X-axis.
Okay. It's not in a quadrant. If you want to comment, you can comment that it is on the x-axis. Okay, -3, -2, point E. Where is that going to take us?
Left or down.
Okay, left 3, down 2. Something like that. And that is in quadrant 3. Okay. 3.5, 7.5. What do you know?
We're at 3.5 up 7.5.
Okay, and we can do that, can't we? So 1, 2, 3.5. Well, my top line there is 8, so approximately something like that. Positive and positive tells us to go right and up. And we are in quadrant 1. That was review, yes. Okay. Our next topic is absolute value. Yes, review, but also a different way of thinking about it, which is what's going to be a little bit different. So, what do you guys remember or know about absolute value?
It's always positive.
Okay. It's always positive. So those absolute value bars take whatever's in it and give it the positive value of whatever's in it, right?
Yes, sir.
Okay. Officially, by definition, it's the distance from 0, distance from the origin, right? So that is your absolute value. Now, there's a fancy definition here. The absolute value of A is equal to itself if A is greater than 0. So that's saying that if your value is positive, the absolute value is equal to itself because it just stays positive, right? This here, if the whatever's inside, if the A has a negative value, or excuse me, if A is less than 0, so if that value in the absolute value is smaller than 0, then the absolute value is going to be equal to the opposite of it. Okay? And then if A is 0, the absolute value is 0. Now, the reason for this fancy notification is when we get to problems like B and C. But, okay, what do you know about A? The absolute value of -4.
4.
Is 4, yes? Inside the absolute value bars has a value of -4. And so absolute value of that becomes 4. It's 4 from the origin. B. Thoughts here?
Just pi plus 6.
No. Now that's the obvious guess, isn't it, right?
You take pi minus 6 and then take that number, round it to 2 decimals,
2
and then
decimals.
change it.
So like,
It's
Okay.
-2.858.
so answer 2.85. Next question.
2.6.
Except I want a more exact answer. I see where you're going with this. So, okay, so here's what you have to think about. Okay, pi minus 6, and I don't even need the calculator for this, but what do you know about the value of pi minus 6?
Be negative.
Okay, can we agree that pi minus 6 is going to be negative?
Yes.
Because pi is approximately 3.14. If I take 3.14 and I subtract 6, I'm getting a negative value. I'm getting that 2 point whatever that Logan gave me, but I don't care about that. I'm getting a negative value. Now, how do we do the absolute value of a negative value?
Make it positive.
Okay, you make it positive, you do the opposite of it. So right here, where if A has a negative value, it says to do the opposite of it. So what that means is I'm going to do the opposite of pi minus 6. So to do the opposite of something, we're doing the negative of it, or we're multiplying it by a negative.
So it'd be negative pi plus 6.
So when we distribute that negative, it does indeed become negative pi plus 6. So that's where you have to be careful. We don't want to just jump at, oh, I see a minus or negative, I'm making it positive. We want to keep the value the same, because if we say the absolute value here is pi plus 6, now we're at 9.14, which is totally different than the negative 2.85 or whatever you had when
Which
in there. Huh?
That's 2.85.
Well, I agree, but I want an exact answer. I don't want us using the decimal version here. So, if you get something you're not sure of, think about whether it has a negative or positive value, and then apply the opposite of it if we need to change it. Okay, what about C? Square root of 5 minus square root of 2. Absolute value of that.
The same thing we just did.
Yeah.
So what do you mean by same thing we just did?
Flip it.
I disagree.
I got nothing else for you. We're not keeping decimals.
Yeah, I'm not going to pick up the calculator on this one. Without picking up the calculator, what does your brain know about the square root of 5 minus the square root of 2?
You can't just subtract 5 minus 2, can you? It's positive.
No.
I didn't think so.
But the square root of 5 minus the square root of 2, square root of 5 is going to be bigger than square root of 2, yes?
Yeah.
So when you do the square root of 5 minus the square root of 2, you're going to get what kind of value?
Positive.
A positive. How do we do the absolute value of a positive value?
Negative.
No.
Or sorry, no, there's nothing. You don't have to.
It just stays the same, right?
that's
So-
four. It's
It's
just
just
square root
the
of
answer.
5 minus
Yeah.
square root of 2.
So we can just circle C.
So if we're doing the absolute value of a positive value, it's going to just stay, we're just going to drop off the absolute value bars and have whatever's in the absolute value bars. Okay? So if whatever's in the absolute value bars always has a positive, already has a positive value, it just stays as is. Because keep in mind, if we would have changed this to square root of 5 plus square root of 2, I've changed the value. And I don't want to change that numerical value. Okay? If, like, pi minus 6, that's a negative, then we do the opposite of everything. So we change the sign of everything. It's a little bit different thinking. But that's technically what absolute value is. You're just thinking about it in a more difficult manner now. Okay? You're used to just having numbers we can add and subtract and go that way. Okay, questions here? Okay, distance formula. Given x1 and y1 and x2 and y2, so given two ordered pairs, there's two formulas here. One of which is our distance formula. Does that distance formula look familiar?
Yes, unfortunately.
You've been using it at least since middle school. Because when I taught middle school math, I know I taught this formula.
Yeah, but you're not Mr. Weaver.
I taught it in 7th grade math.
No, you're not Miss Basher.
Okay, so given two ordered pairs, the distance between x2 minus x1, quantity squared, y2 minus y1, quantity squared, and the square root of them. It's following the formula. Now, the other piece we have, if you just have 2 points on a number line, I mean, we can find the distance between two numbers on a number line pretty easily. But the official formula is the distance of the absolute value of a minus b. Okay? So let's practice real quick. Find the distance between the ordered pair 1, 5 and 6, 2.
4.
I disagree. What are you doing?
You're going to take x1 and x2 and mark them. y1, y2 and mark them. And then you're going to take underneath the square root, you're going to take x2 minus x1 in parentheses and then the square root. So 6 minus 1 squared. plus 2 minus 5 squared. And then 6
Okay.
minus 1.
Okay, I'm gonna pause there. All I did was fill in the formula, yes?
Yeah.
I randomly picked my x1, y1, and x2, y2. Do you have to pick them the same way I did? No, they could be reversed and be just fine. Okay, in fact, if you intermix them, it's not gonna be a huge deal. So 6 minus 1 squared, 2 minus 5 squared, okay. 6 minus 1 is
5.
5, so you're gonna be doing 5 squared. 2 minus 5, negative 3, and we're gonna be squaring that. 5 squared is 25. Be smart. What's negative 3 squared?
No,
9. Don't let your calculators fool you where you say, oh, negative 3 squared is negative 9. You know better. Negative 3 times negative 3 is 9. What do you know about 25 plus 9?
34.
So, you can leave your answer as a square root of 34 if you want. Okay? Could you get a decimal answer?
If you want.
You can. What is the decimal answer? This is a calculator problem, okay?
5.3.
You want it all?
Yeah.
I have 5.83 written in my notes.
5.30951.
Okay.
You're smart. You just don't give yourself enough credit.
We're okay with the distance formula as long as we don't make silly mistakes, yes?
C.
Okay. B.
16.
Find the distance between negative 7 and 9. Thanks, but no thanks. How do we do this?
At 9 and 7.
No way we're doing the full equation.
Okay, and here's the thing. Okay, Logan's gonna argue with me. Surprise, surprise here. But do you have to use the formula?
Not on this one.
I understand what he's saying. The distance between negative 7 and 9. You've made it to pre-calc for a reason. Hopefully you understand 7 left, 9 right. They are 16 apart. Does the formula do it for you also if you're in a more difficult situation?
It can.
It can. Okay, so if I put them into the formula, it's the absolute value of, I put minus negative 7 minus 9. Negative 7 minus 9, absolute value of negative 16. Absolute value of negative 16 is
16.
16. My point to prove that and work it out is, it's a formula for something you already know how to do, really. Okay? So I get it. You don't necessarily want the formula. Okay. Midpoint formula. When I taught 7th grade math, I taught distance formula and midpoint formula at the same time. So I know when introducing them, they came up together. So midpoint formula, again, we have two options here. Given two ordered pairs, the midpoint, you're adding your x's, dividing by 2, adding your y's, and dividing by 2. Basically, you're finding the average of the x values, the average of the y values. Given x and y on a number line, the midpoint between two numbers. You can do the average again. Add them and divide by 2. Okay, so there's the formula you need to know. Find the midpoint of the line segment with the endpoints negative 5, 2 and 3, 7. Again, does it matter which one's x1, y1 and x2, y2?
Yes.
Doesn't matter which is which though. So x1, y1, x2, y2. So in order to find my midpoint, I'm going to start by doing x1 plus x2. So negative 5 plus 3 divided by 2. Add the x's, divide by 2. And then the other part of that, I'm going to add my y's and divide by 2. Negative 5 plus 3 is?
2.
Negative 2 divided by 2 is?
1.
Negative 1. 2 plus 7 is?
9.
Divided by 2? 4.5. I left mine as 9 halves. Realize 4.5, 9 halves. I'd be happy with either or. So -1, 9/2. Now, the midpoint of -6 and 9. Can your brains handle that without a formula?
Yes.
If you think about it enough, okay? You're finding the middle of those two. Or, what's the formula say to do?
Add -6 and 9. Add x and y divided by 2.
-6 plus 9 divided by 2. -6 plus 9 is
3.
3 divided by 2 is 3/2 is what I'm going to say. Okay, I tend to leave things improper. You could, I guess, if you want to, say 1.5, whatever. Okay? So, again, I get it. You don't need the formula, you don't need the formula. Okay,
Let's do it.
on the back side, well, not too difficult of a next topic, standard equation of a circle. I'm not getting through the whole back page, so we'll talk about it tomorrow. Okay? Now, with that in mind, the back page is going to take me far from the entire class. Bring your books with you tomorrow. You will have work time. Okay? So, we'll finish the back page of notes. Bring your book or iPad. So here's the deal. You have to bring your book tomorrow. No, you can bring your iPad because your book is on the iPad. Okay? You do you. Okay? We can look at, I know several people in my afternoon class who are talking about downloading the book. That is definitely an option. You don't want to use the book on Schoology because it just glitches like crazy, but you can download it to your iPad where you can just, it looks like it works fairly smoothly from what I've seen watching people use it.
Yeah, you just gotta scroll through like 30 pages.
Okay, it is, that might be the problem, is getting to the page. Now, page 17, 2 through 18 evens, 24, 26, 28, 38 to 52 evens. That's listed up there. Is it due tomorrow?
No.
No. That will be due
No.
Monday. Okay? There's a little bit you can work on if you want to get started, but you'll have time in class tomorrow as well. Okay?
Page 17 is really like page 50.